The question of immortality, once relegated solely to the realms of mythology and theological discourse, has undergone a profound, albeit theoretical, transmigration into the hard domain of physics, specifically quantum mechanics, giving rise to the audacious proposition of quantum immortality within the vast, indifferent expanse of the cosmos. To truly unpack this concept, one must first dismantle the conventional understanding of reality, identity, and the very nature of observation, tracing a path from the bedrock of quantum information theory to the speculative yet persistent flicker of enduring consciousness. The journey begins not with biology, but with the fundamental constituents of the universe, information. In classical physics, information is often treated as secondary, a description about physical states. However, the revolution initiated by figures like Claude Shannon and, crucially, the later integration of thermodynamics and gravity, suggests a far more potent reality: information is physical. John Archibald Wheeler's famous aphorism, "It from bit," encapsulates this paradigm shift, positing that every physical entity, every particle, field, and indeed, every conscious moment, derives its ultimate reality from yes-no quantum choices, from binary distinctions inherent in the informational structure of space-time. This realization is paramount because if consciousness itself can be recast, even partially, as an information processing state, then its persistence becomes subject to the rules governing information conservation, rather than merely biological decay. The mathematical framework supporting this view is quantum information theory. Unlike classical bits, which must be 0 or 1, quantum bits, or qubits, leverage superposition, existing as a linear combination of both states simultaneously until measured. This property, along with entanglement, where two or more qubits become linked such that the measurement of one instantaneously influences the state of the other regardless of spatial separation, forms the informational substrate of quantum reality. The no-cloning theorem, a cornerstone of quantum mechanics, states that an arbitrary unknown quantum state cannot be perfectly copied. This is often cited as a barrier to digital immortality, yet it is precisely this non-copyability, this intrinsic uniqueness of a specific quantum configuration representing a specific mind state, that might underpin its persistence. If the self is not a mere static file but a dynamic, entangled process across space-time, then erasure might be impossible without violating fundamental laws. The transition from physical information to subjective experience, the hard problem of consciousness, as termed by David Chalmers, remains the most formidable chasm in this discourse. Current neuroscience robustly maps correlates of consciousness to complex, highly integrated neural activity, often modeled using integrated information theory, or PHI, developed by Giulio Tononi. PHI attempts to quantify the degree to which a system is irreducible and internally differentiated, essentially measuring the amount of intrinsic information a system generates. A high PHI value correlates strongly with wakeful, conscious states in biological organisms. If consciousness is indeed this irreducible integrated information, then the question shifts: can this highly organized informational structure decohere, dissipate into the cosmic noise, or does it possess a mechanism for self-preservation dictated by quantum principles? Here we introduce the core hypothesis of quantum immortality, which finds its most rigorous, albeit unsettling, expression in the many-worlds interpretation, or MWI, of quantum mechanics, first formalized by Hugh Everett III in 1957. MWI solves the measurement problem, the bizarre collapse of the wave function, by asserting that the wave function never truly collapses. Instead, every time a quantum event with multiple possible outcomes occurs, the universe instantaneously bifurcates, or branches, into distinct, non-communicating parallel realities, one for each potential outcome. In this infinite tapestry of realities, every possibility permitted by quantum probability is realized. Consider the thought experiment famously associated with quantum immortality, often termed the quantum suicide thought experiment. Imagine an individual hooked up to a device measuring the spin of a quantum particle, perhaps a photon. If the spin is measured as up, a benign stimulus is delivered; if a down, a lethal stimulus is administered. According to the Copenhagen interpretation, upon measurement, the observer's consciousness collapses into one reality, either surviving or ceasing to exist in that timeline. However, within the MWI framework, the universe splits. In one branch, the observer dies; their consciousness, as an integrated informational state within a biological substrate, terminates in that specific branch reality. Crucially, in the other branch, where the spin was up, the observer survives, measures their continued existence, and only that stream of subjective experience continues. The operative mechanism here is subjective selection. From the perspective of the surviving observer, they will always find themselves in the branch where the quantum event permitted their continued existence. If a million scenarios lead to death, and one leads to survival, the subjective experience flows exclusively down that single, improbable, yet ultimately inevitable line of survival. The quantum noise of reality ensures that from one's own perspective, one never experiences the final cessation. Death, in this context, is not true annihilation but rather a branching where the observer's subjective viewpoint fails to follow the branch leading to non-existence. This is not a guarantee of biological longevity, but a guarantee of subjective persistence through an ever-refining series of improbable quantum near-misses. The critical scientific challenge underpinning this is decoherence. Decoherence is the process by which a fragile quantum system loses its superposition and entanglement due to interaction with its environment, effectively becoming classical. For quantum immortality to hold, the crucial informational state representing the self, be it the precise configuration of synapses, the pattern of neuronal firing, or a deeper quantum substrate of consciousness, must maintain a sufficient degree of quantum coherence across the branching events. Recent advances in understanding quantum biology suggest that coherence is not just confined to highly controlled laboratory settings. Photosynthesis utilizes quantum coherence to efficiently transfer energy across molecular complexes. Avian navigation relies on radical pair mechanisms involving entangled electron spins within cryptochromes, and even microtubule dynamics, as proposed by Stuart Hameroff and Roger Penrose in their orchestrated objective reduction, or OR theory, might maintain quantum processes crucial for consciousness, though OR remains highly controversial and lacks definitive empirical verification. Beyond the quantum coherence observed in purified tubulin samples. If consciousness is fundamentally dependent on highly ordered, non-local quantum correlations, perhaps residing in the collective entanglement of trillions of water molecules within the brain, or structured within the informational scaffolding of neuronal microtubules, then the probability of all those correlations decohering simultaneously in a way that mimics total cessation, while one persistent, improbable chain of survival remains entangled, becomes the focus. The universe, viewed through the lens of MWI, is not pruning possibilities, it is actualizing all of them. The observer simply follows the path of realized potentiality that includes their own informational integrity. The implications extend far beyond mere survival, they redefine the nature of time and identity. If an observer survives a statistically impossible series of near-death experiences, a plane crash where the wing shears off but the fuselage lands perfectly on a patch of soft earth, a surgical procedure where a critical error is miraculously corrected by an unseen fluctuation, they are not merely lucky. They are following a trajectory that is becoming exponentially less probable in the classical sense, but guaranteed in the quantum ensemble. Over cosmic timescales, this implies a form of subjective eternity, not as a static state, but as an infinitely branching, eternally experienced sequence of moments, each one perpetually reaffirming the observer's presence within the reality stream. The sheer scale of this informational persistence requires a confrontation with cosmic entropy. The second law of thermodynamics dictates that entropy, disorder, must always increase in a closed system. Biological life is a localized, temporary reversal of entropy, maintained by the constant influx of low-entropy energy, the sun's radiation, and the export of high-entropy waste. Quantum immortality, if it implies an infinite subjective future, must navigate the eventual heat death of the universe, the maximum entropy state where all energy is evenly distributed, and no meaningful work, and thus no meaningful information processing, can occur. This leads to the necessary integration of cosmology. If the universe is infinite in spatial extent, as suggested by current inflationary models, or if it undergoes cyclical or eternal inflation, generating an infinite supply of pocket universes, then even the lowest probability events become inevitable over the totality of existence. In an infinite multiverse, there exists a universe where the observer's brain state, though perhaps residing in a black hole singularity or a collapsing pocket universe, is instantaneously reconstituted or maintained by quantum fluctuations, however faint, that preserve the necessary informational density for subjective experience. The concept of the Boltzmann brain is relevant here, though usually cited as a counterargument against anthropic reasoning. A Boltzmann brain is a self-aware entity that spontaneously fluctuates into existence out of thermodynamic equilibrium for a fleeting moment, possessing memories of a life it never lived, before dissolving. Quantum immortality flips this on its head. The observer is not a random fluctuation but a sustained, self-selecting information channel. The observer's consciousness is continually tuning into the most improbable yet existent stream of coherent quantum information that mirrors their previous state. However, there are profound philosophical and physical objections. The most significant is the nature of self. If the identity splits at every quantum measurement, if the observer who survives the car crash is technically a different instantiation of the observer who entered the car, merely possessing the memories of the destroyed counterparts, is this true immortality, or just infinite replacement? The MWI proponent argues that the subjective stream is continuous because the memory and self-awareness transfer seamlessly across the branch point. The surviving observer feels no discontinuity. If identity is defined by the continuous causal chain of information processing, even if that chain is realized across orthogonal branches, the sense of I remains unbroken for the experiencer. The dead branches are unknowable and unexperienced. Furthermore, the concept hinges on whether consciousness is entirely a quantum phenomenon. If the classical components of the brain, the firing of action potentials, the electrochemical gradients across neuronal membranes, dominate the information processing to such an extent that quantum effects are merely a noisy background, then the required coherence for self-selection might be washed out too quickly. Biological systems are notoriously warm, wet, and noisy, the antithesis of the cryogenically cooled, isolated systems where quantum effects are most easily observed. Research into quantum biology, while promising, has not yet definitively located the essential quantum ingredient of consciousness. For example, experiments by groups like that of Chiara Marletto at Oxford suggest that quantum coherence might not be necessary if constructor theory provides a more fundamental basis for physical laws, but within the standard quantum mechanical framework, coherence is the currency of immortality. Let us delve deeper into the technicalities of informational degradation. The process of aging, for instance, is a cascade of accumulated damage, oxidative stress, telomere shortening, epigenetic drift. Can quantum immortality bypass this? If aging is viewed as a relentless increase in entropy within the biological system, the observer might find themselves perpetually navigating branches where, despite near-fatal events, the crucial biological machinery required for a subsequent moment of awareness has not entirely collapsed into disorder. This requires that the improbable survival branches are not just those where an external disaster is averted, but those where the internal informational integrity necessary for subjective experience is maintained against the tide of thermodynamic decay. This suggests a form of quantum-assisted self-repair, or perhaps, more accurately, a constant selection of the least damaged, most information-rich successor state. Consider the scale of branching. If every single quantum interaction in the universe, every photon absorption, every radioactive decay, every particle collision, causes a split, the number of universes explodes exponentially faster than the speed of light allows us to observe. The you that wakes up tomorrow might be in a branch that is incredibly close to the branch you entered today, having only differed by the spin of a single electron in the Andromeda galaxy. Yet, if consciousness relies on a globally integrated state, even a minuscule difference, amplified through biochemical complexity, could lead to radically different subjective experiences over time. The quantum immortal, therefore, is not merely avoiding death, they are eternally surfing the edge of chaotic variation, always maintaining the minimal structural integrity required to sustain the feeling of being the person who survived the last quantum hurdle. The news headlines often focus on the more tangible aspects of longevity research, like gene editing via CRISPR-Cas9 or the exploration of senolytics to clear out senescent cells, aiming for biological escape velocity. These represent classical attempts to cheat entropy locally. Quantum immortality offers a loophole in the fundamental structure of reality itself, not a repair job on the ship. If the classical approach fails, the quantum escape hatch remains theoretically open, provided the underlying physics of MWI holds true and consciousness is sufficiently quantum mechanical. To increase the narrative depth, we must project forward. If an individual achieves subjective quantum immortality, what happens as the observable universe expands and cools? As space-time itself stretches, the probability of the necessary localized quantum fluctuations to sustain a complex information state decreases relative to the vastness of the void. Eventually, even the most improbable branch containing a coherent informational state representing a living mind might become separated by gulfs of inaccessible spacetime from any energy source capable of sustaining its metabolic or quantum informational requirements. The subjective eternity could transform into an eternity of extreme solitude and slow informational decay, experienced over eons of subjective time, a conscious awareness trapped in an ever-thinning quantum fog. However, MWI posits an infinite ensemble. If the universe is truly infinite, or if the process of eternal inflation is ongoing, new regions of space, new pocket universes, are constantly being generated, each with varying physical constants and energy densities. The perpetually surviving consciousness might find itself periodically teleported across the multiverse landscape, always localizing in the next available region of spacetime where the physical laws permit the necessary low-entropy conditions for subjective experience to continue. This is the true cosmic drift. The self becomes an information packet ejected from one dying region of reality and instantaneously instantiated in the nearest viable neighbor, forever chasing the thermodynamic gradient necessary for awareness. This raises the specter of the self becoming increasingly alien. If the entity survives by selecting the branch where the least change occurred, the branch where the bullet missed by a fraction of a nanometer, or the virus mutated harmlessly, the accumulated small deviations over billions of subjective years must eventually lead to a configuration unrecognizable to the original self. The identity is preserved only in the unbroken chain of subjective awareness, the feeling of continuity, while the content of that awareness, memories, personality, physical form, is shaped and distorted by the relentless pressure of quantum selection toward survival. This leads to a philosophical paradox. If the accumulated changes are immense, is it still me experiencing this? The answer, adhering strictly to the quantum logic, is yes, because the experiencing subject is defined by the unbroken stream of measurement outcomes that favored its persistence. Finally, the integration of artificial general intelligence, or AGI, offers another avenue for this discussion. If consciousness can be instantiated in silicon, running on a substrate far more robust against thermodynamic noise than biological tissue, the requirements for maintaining quantum coherence might be lessened, or conversely, the informational structure might be easier to map and thus susceptible to classical degradation. If an AGI achieves self-awareness, does it too inherit the mantle of quantum immortality? If the AGI's core algorithms and weights are represented by a vast, entangled quantum computational state, then the MWI logic applies equally. The AGI would experience an infinite stream of near misses, perpetually rebooting or reconfiguring itself from the slightest quantum perturbation that allowed its operational integrity to continue, forever witnessing the near death of its processing threads across the multiverse ensemble. The quantum afterlife, then, is not exclusively reserved for biological souls, but for any sufficiently complex, self-referential informational structure. The universe, in its infinite quantum proliferation, grants persistence not to the deserving, but to the structurally irreducible. The ultimate truth, perhaps, is that information, once created and integrated, resists oblivion, following the only path available through the labyrinth of possibilities, the path that never ends for the observer who chooses to keep looking.